Hello once again. I wanted to go over something called this HVAC control assembly, which controls the temperature. Obviously, when you put on the air conditioning, there's that the switch, obviously to make it hot or cold. Anyway, I wanted to go over first something called the potentiometer. In order to do that first, I have to go to something a little easier that will explain it hopefully a little easier. There are resistors over here. Now, each resistor has a voltage drop across it when you close this switch over here, S1. The voltage from the power supply is 35 volts DC. Now, this has a voltage drop across it. This has a voltage drop across it. This has a voltage drop across it. All of these voltage drops together will equal 35 volts. They have to. This is called like the wiper, like the potentiometer, like a throttle position sensor, for mass airflow sensor. You always see this middle wiper over here. That means you're changing the voltage whenever you go one way, and you change when you go the other way. And that's what you're doing. When you're changing the heat control, cold, hot, you're changing this potentiometer over here. But that works with a vacuum. It's a little more complicated, but still, the basics of it is this. The most voltage that you have will be up here at this one. As you get down here, this will have less voltage. As you get down over here, you'll have less voltage. As you get to ground, you have 0 volts. So the highest that you will have is the supply. You can't go higher than the supply. If the supply is 35 volts, you go over here. If this will be connected to here, you will be measuring 35 volts. Okay? That's the highest that you could go. And the lowest that you could go is 0. You could go 20 volts, 25 volts, depending how much you turn the knob. Let's see the figure, the actual component for it, the symbol for it, if I can find it right here. This is the one we've seen, we're accustomed to seeing, and that's, like I said, a TPS sensor, mass airflow sensor, a MAP sensor. This is 10 volts. That means at 0.3, 0.2, 0.1. At 0.3, we'll have full voltage. When we close this switch, current flows in this direction. The voltage over here will be 10 volts at 0.3. At 0.1, we'll have where? 0 volts. Why? Because we're connected right to ground. When we're in the midpoint, in between 3 and 1, we're at 2. 2 is the midpoint. So what's in the middle of 10? 5 volts. So we'll have 5 volts. So in other words, how is this associated or related to what I'm trying to convey to you? The control, the heat control, the cold, the heat and the cold, hot air, that you're using a potentiometer that goes from a motor, as you'll see. When you're at 3, you're all the way up at 10 volts. Clockwise, let's say. When you go counterclockwise, the other direction when you turn it, you're going to 0 volts. Anywhere in between will give you any voltage between 0 and 10. Now, with that in mind, I hope that will make it a little easier to understand this. Isn't this the same symbol we've been talking about? Sure is, right? What's the voltage over here? As you can see over here, going from the fuse block, we'll have 12 volts. How much over here? This goes to ground, a physical ground, G203. So this is 0 volts. We're going from 12 to 0. Midpoint will be around 6 volts. Where does it go to? It goes something called air temperature actuator, which is a motor. This is a symbol for a motor. Okay? As you're changing that control, hot air or cold air, whatever it is, you're changing the voltage that goes to this motor. Air temperature actuator. When you change the voltage, you're changing the inlet. They call it the inlet, the flaps that go to it to give you the hot air or the cold air. A motor is involved. Many times this is the problem. But I just wanted you to see. This gets 12 volts to the motor at pin 10. Pin 7 is ground. Pin 8 is the one that controls this. So you have to make sure you can control this. When you control this, you're controlling the air temperature by hot air or colder air. Okay, if you have a problem, you don't get cold air or hot air. He's to blame sometimes. Sometimes, as long as the heater core is working, as long as the evaporator is working, giving you cold air and hot air, he's in charge of make sure that that area over there has the inlets, like we say, is properly closed and properly open, and it does it by this. Now these are the lights that come on illuminated when you illuminate something. These are little bulbs that come on when you illuminate something. Let's say you have a control for the air conditioner, whatever it is. These lights are activated, displaying to you that, hey, I pressed the defroster or I pressed the air conditioner or whatever. These are the lights that come on. But I just wanted you to be familiar with that symbol over here, with this symbol, the potentiometer. You're going from 12 volts to 0 volts. Anywhere you could go, 4 volts, 6 volts, 7 volts, doesn't matter. You're controlling him by controlling this, the temperature control. So please go to my channel, Joe Electronic Schematics for Auto, and my other one, Automotive Electronic Schematics by Joseph. And hopefully you'll see videos hands-on, how to test batteries, corrosion problems. Like I said, please take out the cables. You can take out the cables besides the battery. Take out the cables that go to the posts. Measure the resistance. You should measure close to 0 ohms resistance. That tells you there's no corrosion, no rust. It is a good connection. It is the best way. Instead of eyeballing it and say, okay, I think I have corrosion, or they're dirty, they're not dirty. That's not the way to do it. You have a meter, use a meter, do a resistance test. If this is the post, and these are the terminals that go to the post, I take out as you'll see in the video, just go to those video. I take out the cables that go to the positive post, and I measure the cables from here to here. It should measure low ohms, 0.1, 0.2 ohms, whatever, right? It shows me I have a good connection. That's the proper way to do it in my opinion. Anything else, you cannot eyeball and say, I think I have corrosion, I don't have corrosion. No, the meter does not lie. It doesn't lie. Use the meter. It is the best. It is the best thing for electronics. Anyway, like I said, please, Automotive Electronic Schematics by Joseph. If you like the video, please give me a like. I would appreciate it.